great story.
This last topic is the Lagrange error bound. I don't know if you remember, but we did cover it when we did the alternating series error bound. Actually, this was the question you guys all nailed on that test. Do you remember how the error is less than the next term? Okay, the same concept here. So I'm gonna write out our in general formula for how we get our Taylor polynomials. So remember, it's the nth derivative at wherever you're centered, which I've never seen one of these be anywhere other than 0. So in theory, it could be centered somewhere else, but I've never seen one. So just assume it's going to be Maclaurin. Assume it'll be centered at 0. All right, over n factorial, and then x minus c to the n. That's the formula. I just went over that when we went over the quiz. It was in question 2 or 3. Remember, we wrote out the whole thing. That's the in general formula. Again, these ones will be 0, though. I've never seen one that's not 0. Okay. So when you go to do this, do you see, and I just want you to compare and contrast these. Do you see how it's x minus c to the n plus 1? Instead of an n, it's an n plus 1. And then instead of n factorial, this is n plus 1 factorial. And this derivative is the n plus 1th. You're probably like, why is that z? I'm going to talk about that in just a second, why it's a different letter of the alphabet. So for the Taylor polynomials, the f of x is the actual value. So that's like the perfect answer. What we get from our polynomial is the approximation. And so what's left is the remainder. And if you absolute value that remainder, that's what we call the error. The reason we absolute value it is because you could be off by a little bit either direction. So we just absolute value it, and that's your error. So it's whatever your approximation is plus how much you're off by. Okay. And that error is going to be smaller than the next term. Okay. So I'm going to talk about what all of this is. N is your degree. And they're going to, usually tell you that, use a second degree polynomial or whatever. C is where it's centered. And again, I haven't ever seen one that's not 0. So again, in theory, they could do that to you, but I haven't seen one that's not 0. X is the value you're approximating. And then there's that z value. Okay. You can't get that exactly. If you could, you wouldn't need an approximation. You'd be able to just get the actual value. Does that make sense? You wouldn't need to approximate if you could find that. Here's what you're going to do. You're going to plug in C and X. So where it's centered, that'll be 0, and X, and use the larger one. We use the larger one because we're trying to say our error is smaller than whatever we get. So if you use the larger one, your error will be smaller than that. Okay, but we don't actually know that number. So you use X and you use C and you pick the larger one because we can't actually get that. Okay, so here we go. Number 1, I'm going to list all this stuff out to the side. First thing is I want to know what power we're raising this to. So read through, they'll tell you what is our degree. Third degree. Where are we centered? 0. See how it says, it should have just said Maclaurin, but it said Taylor polynomial about 0. So C is 0. What is X? 2. It's like the only other number that they gave there. X equals 2. Okay. So here we go. We're going to find the n plus 1th derivative for this formula. They're kind of giving us a way around this because, again, this is the piece that you kind of can't do. You don't have that piece of information. So sometimes they'll do this and they'll give you a formula as a way to bypass that. But we're not going to plug in 3. And that's the thing that does throw people off. You're not plugging in 3. You're going to plug in 4 because it's the n plus 1th. Okay. So we're going to plug 4 into this formula. That'll give us the first little part. All right. So if you plug in 4, what do you get? 16 over 5. that is this portion that I just circled here. You know what? I'm actually going to pause and write this on the board in a second, so I don't have to keep moving the paper up and down. But that part I circled, that's what we just got there. They give us a formula to get it. All right, the next part is x minus c. Now that would be 2 minus 0. If you don't want to write the minus 0, you don't have to the n plus 1th power, which good. That's the tricky thing, is people will see that they said third power and use 3. You always have to add 1 to that. Remember, error is the next term. And then it would be over n plus 1 factorial, so 4 factorial. And we're just going to kind of boil that down and see what we end up with. So 16/5. This would be 2 to the 4th, which is 16. And then what is 4 factorial? 24. Now, I asked you to get a calculator, but let's pretend you didn't have one for this. I would not try to do 16 times 16. That is 256, but let's try to keep the numbers smaller. Ignoring the 16/5 for a second, like if we just left that in there, how could you reduce this? Yeah, it would be 2/3, right? So now I'm going to do 16 times 2, which would be 32. And that 5 can come down to the denominator. So 5 times 3 is 15. Okay, so look at the next one. Read through. What is n? What is the power? Second derivative. Okay, but that means we're not going to use 2. We're going to use 3. So you just have to remember that. All right, c is 0. It says Maclaurin. That means centered at 0. X is 0. Good. We're going to need a calculator for this one. Okay. So here's our function. We're going to need to go to the third derivative. We didn't get a formula for this one. This was given a formula where we could just plug in and it got handed to us. Not the case here. So we're going to have to go all the way to the third derivative. All right. Now you want to think of this as 1 minus x to the -1. If you can hold that in your mind, you don't need to write it, but that's how you want to think of it. So the -1 would come down. It would be 1 minus x to the -2. And then you would have to chain on the derivative of what's inside, which would be -1. So the negatives are going to cancel. And again, we have to go all the way to the third derivative. So keep on going. So next one, you would bring down the -2. It's going to drop to a -3. But then you have to chain on the derivative of the insides, which would be -1. So again, the negatives are going to cancel. That's going to happen every single time. All right, and then one more, third derivative. You would bring down the -3. That would give you -6, drops to a -4, and then you chain on a -1, and the negatives cancel. I am going to rewrite that without the negative exponent, so it'll look a little bit nicer. It would be 6 over to the 4th. Good, perfect. And again, we went to the third derivative because our power was 2, and you go 1 past that. So now we're going to plug into our formula. That first part is going to be our third derivative at z, except we don't have z. So we're going to plug in c, and we're going to plug in x, and we're going to use whichever one is bigger. Okay, now c is 0. So if we plug in c, let's just see what c gives us. If you plug in 0, that would just be 6, right? Now, if we plug in x is 0.1. I want you all to take your calculator and plug 0.1 in for x to this thing, and we'll just all see what we get. And we're going to use the larger one. Because again, what you're trying to say is your error is smaller than what you end up with. So if you pick the bigger one, you know your error is going to be smaller than that. Anyone feeling brave? You want to share? 9.1. Perfect. 9.144. Just don't clear that out. You can either store it. We're going to need to reuse this number. So you can either store it, do store alpha A, enter if you want. You know, it looks like a bunch of you are doing that. I was going to say just leave it there, but it looks like you guys are storing. So I'll just do the same as you. So we stored it. Now you can clear all that out and we have that captured. right? Now that's the bigger one. So that's the one we're going to use. We're not going to use this one. So that 9.144 is that first piece of the formula. That's the hardest part to get. All right, now we're on here. X minus C, which would be 0.1 minus 0. If you don't want to write the minus 0, you don't have to. To what power? Because it's not 2. Good. And then over 3 factorial. You're going to put that in your calculator. What you get is your answer. Just make sure you don't type 9.144. Make sure you type alpha A, what you stored. Did you get a teeny little decimal? You should, because the error in theory should be very, very small. Do you know what I'm saying? Like error should be small. We want a small error. Did you get 0.0015? Okay. I know we only have to do 3 decimal points, but I usually go kind of further with these ones because they're so tiny. So up to you how you want to do that. But because they're such tiny decimals, I usually like go more than 3 decimal points because otherwise it would be 0.001. There is. If you go in the math menu, hit math, and go over to PRB, which is probability, it's the 4th one down. I just memorize them up through 5 though. So like I just knew 3 factorial was 6 and I just typed a 6. But if it goes beyond that, like if you needed to do a 7 factorial, like I don't have that one memorized, then there is a button for that. All right, go ahead and read through. What is n? What is our power that we're looking for? 2nd, but that means we're going to use 3. All right, and it says Maclaurin, so we're centered at 0. Again, I've never seen one of these not centered at 0. And what's our x value? 1. So that first part, we want the 3rd derivative at z, but we don't have z. So we're going to plug in C and we're going to plug in X and whichever one is bigger. Now, do you see how they handed us the 3rd derivative here? So we didn't have to actually find all of them. And a lot of times they'll give you a shortcut like that, like a formula that you can plug into. All right, so we're going to plug in C and we're going to plug in X and we're going to see which one's bigger. So C is 0. If you plug 0 into this, e to the 0 is 1. If you plug in 1, you get e squared. So which one's bigger? E squared. So that's the one that we're going to use. So that first part of your formula is e squared. And then it would be x minus c. So 1 minus 0 to the what power? 3rd, good, over. Perfect. And you're going to put that in the calculator and that's your answer. The E button. Do you see ln? It's kind of next to the 4. E is right above that, so you're just going to hit 2nd. So 2nd ln will get you that. Did you get 1.231? That's kind of a large area, or error. I'm sorry, area. Jeez Louise. That's kind of a large error. But it's because the function was exponential. So you can be off by quite a bit with exponentials. Or did everyone get that in their calculator? I didn't hear any complaint. All right, now this one's a little bit backwards. It says determine the degree. So we don't actually know what n is. Womp womp. It says Maclaurin, so we're centered at 0. And what is x? .6, good. Now here's the nice thing about e. What's the first derivative for e? E. And what's the second derivative for e? And the third derivative? So we don't like know what n is, but we know the nth derivative is e, okay? You really couldn't get away with this with any other function because you wouldn't know what your nth derivative was, but it's going to be e to the x. So again, for this first part, I don't know what Z is. What are we going to plug in instead? C and X, and see which one's bigger. So I plugged in 0, I plugged in 0.6. Again, it would just be e to the x. I don't know what n is, but I know the nth derivative is e to the x. So e to the 0 would be 1. Can you type in e to the 0.6, second ln 0.6? Well, 0.6 is bigger than 0, so it is going to be bigger. Yeah, but not by much. What did you get? 1.822. So we want to use that one. Go ahead and store that. Store alpha A, enter. Store alpha A, enter, store that so we can use that. So that's going to be our first part of the formula. And then you have x minus c to the n plus 1. We don't know what n is. Again, bummer. And then down here, we'll have n plus 1 factorial. And we want this to be smaller than .001. Okay, you're not going to like this very much, and I don't really like this either, but this is kind of the way it is. You're going to be like, hey, what if n's 2? Hey, what if n's 3? Hey, what if n's 4? Hey, what if n's 5? And just plug it in until you get something that's smaller than .001. Oh, yeah. Your face kind of sums up how I feel about it too. But there's not, can you think of another way to do it? Oh, you like this? Just guess and check? Okay, cool. This is your thing then. So we're gonna do, now make sure you use alpha A instead of that 1.822. All right, so alpha A times 0.6 to the power, what do you want to try for n? It'll be bigger than 1. Let's try 3. 3 plus 1. I know 3 plus 1 is 4, but let me show you why I did that. Okay. And then down here, I'm going to do 3 plus 1. Oh, and we will use the factorial button for this one. So I typed all that in. Is that result smaller than .001? No. No. So watch how I'm going to do this so I don't have to type the whole thing all over again. Just go up, hit enter to bring it back. And if you change the 3s to 4s, and then just hit enter, you don't have to type the whole thing all over again. Is that smaller than .001? No. So go back up, change the 4s to 5s. It'll be small enough this time. Oh, so what happened was it wrote it in scientific notation. Do you remember blah, blah, blah times 10 to the whatever? It's times 10 to the negative something. It moved the decimal point so many times that it did that. But anyway, when we got to n being 5, it was small enough. So n is 5 is the answer for that. So you can plug that into the table. Your formula. I've never done that. But yeah, are you saying put it into y equals and then go to your table? My only thing with that is I don't know how many decimal points the table goes out to, and you might need more than what it's showing, is my only caution on that. It would work. You're right. 100%. I'm just not sure how many decimal points it goes, and you might not be able to see as far as you need to, is the only thing I'm going to say about that. Okay, 2 more. We can do it. Given this polynomial, which does not have a whole lot of information in it, what's our n value? What power are we using? 2, but that means we're going to use 3. Okay. Yeah, it says second degree. So n is 2. It says about x equals c. So we're centered at c. That's not really a whole lot of information. And actually, x is just x as well. You don't really need to write that, I suppose. They didn't give us a whole lot of information there. Everything is sort of just in this like general formula. We don't have like a whole lot of information. All right. But since we want n to be 2, we need to go to the third derivative. So here we go with our derivatives. We're going to go all the way to the third one. All right, first derivative. This would be a constant, so what's going to happen to it? It's gone. And then what's our derivative for this part? A 1, there we go. Plus, now here you would bring the 2 down. So it would be 2a2x plus, and then here you would bring the 3 down and it would drop to a 2. It's very like in general, like there aren't any actual numbers in the problem. Well, here, we're going to try it again. What would be your derivative of just the a1 part? Yeah, it would go away because that's a constant. What would your derivative of this term be? Yeah, 2a2. See if we're going to get the hang of it. 2a2 plus, and then here you'd bring the 2 down. It would be 6a3x. Perfect. And then one more. Again, n was 2, so we have to go to the third derivative. So this first part, 0. There's not an x in it, right? So that's a constant. That's going to go away. And then what's your derivative of this part? Perfect. So that is the first part of your formula. And then it's going to be x minus c. We don't know what x is and we don't know what c is, but we do know what power this is going to be. What's the power going to be? Good. And then over 3 factorial. Technically, that's it. That's the answer. However, what is 3 factorial? 6. So the 6's would cancel out. And so technically, it would be this. One more. All right. What power do we want for this one? So n is 3, but that does mean we want 4. C is 0 because it says Maclaurin, and x is 0.1. Cool. All right, so we need to go to the fourth derivative. What is your first derivative? Derivative of sine. Cosine. This is going to do a lot of back and forth here. Derivative of cosine, negative sine. Derivative of negative sine, negative cosine. And then derivative of negative cosine is sine. I wrote them all out to show you, but if you remember that they cycle every 4, if you want your fourth derivative, it's the same as what you started with. Does that make sense? If you just want to remember it's every 4. So if you wanted the 8th derivative, it's what you started with. It would be the same for cosine. All right, so we don't know what z is. What are we going to plug in instead? Yeah, x and see which one's bigger. So c is 0. If you plug in 0 here, what is sine of 0? -0. Sine of 0 is 0. Sine of 0.1 is going to be bigger than that, just as a heads up. Okay, so that's the one that we're going to use. So that first part is sine of 0.1. What comes next? I've got the formula on the board right behind me, and this is the last one, so I'm throwing it on you guys now. What's going to come next? Good, so that would be 0.1 minus 0. Can I not write the -0? You can put -0 if you want. I wrote it for all the other ones. It's going to be 0 to the power 4 over 4 factorial. Slam that in your calculator. Oh, make sure you're in radian mode. It hasn't mattered up till now, but we're doing trig now. So it will matter for the trig. So make sure you're in radian mode. Did you get something in scientific notation? Yes. I did this differently on that paper. This, did you get 4.159? Blah, 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 e to the negative 7th. That means that you want to move the decimal point 7 times. So if you move it once, it would be in front of the 4. And then if you move it 6 more times, so you're going to have 6 zeros and then a 4159.